Okay. Hello. Thank you for being here. We're very excited to see so many people in a technical meetup. Thanks to Kasia and Adria. So my name is Xavi. I'm representing Vocdoni here. Vocdoni has already a couple of years old. We are a team of 8. And what I'm going to do here is I'm going to do first a little introduction about what are we aiming for, what's Vocdoni about, what have you been working for. And then Pau will go deeper into the meat of the project and the more technical stuff. So Vocdoni in Esperanto could be translated to give voice. And our purpose is to provide tools to overcome the technical challenges that we believe are fundamental for a free and fair society, right? That seems very big, but we seem there is missing very fundamental primitive that still do not exist. And we would like to provide not only technical means, but also social and political means to achieve this purpose. Okay. So we start with this very simple question. We think it's a very fundamental question, and I think I'll go deeper now, but I think we can summarize what we're trying to do with this question, right? How can millions of people vote from a smartphone? It seems very easy, or relatively easy, right? So much has been talked about voting, universal voting, blockchain and stuff, but the reality is that right now it's not possible. This does not exist at all. What we think a true voting system is, right? It's anonymous, it's tamper-proof. Tamper-proof also including here, we didn't put it at the end, but censorship-resistant is an important property that we do care about. Tamper-proof meaning if the system is corrupted, at the very least you know that it's corrupted, right? Universally verifiable, that's the single property that no single system in production has right now, right? And for that we mean that any observer of the network can verify that a vote it's counted correctly, and that the user in itself can verify that its own vote has been counted, right? And also the integrity of the system it's working fine. That's only possible now because of blockchain and stuff, right? And then scalable to millions. There's a lot of theoretical words on how to do voting. But once you put that in the production, when you want not 10 people to vote or 1,000, but millions of people to use the system, the things become a little more complex. And then can be used from a smartphone, right? We've seen systems that are, think like Zcash, right? It's an anonymous system, it's distributable, maybe millions of people can vote, but can you do a shield transaction from a smartphone? I don't think it's possible still, right? It's very hard to move all these, Jordi was talking before, right? You need pretty hardcore machines for doing this computational work to prove anonymous stuff, and that's very hard to do, right? So that's one of the things that most of the systems fail to do. So how are you doing that? Pau will get deeper into that, but yes, we're using blockchain. We have our own blockchain, and we're also using Ethereum as a source of truth. Zero knowledge proofs. Jordi has helped us a lot. Adria has helped us a lot. There's a lot of people in this room that have brilliant knowledge and working with us to use that. Public key cryptography, of course, and no trusted components. So what we're doing, we are a lot of the load that the smartphone should have, we are outsourcing it to servers. And we can do that because they're trustless, right? And that allows a very pretty high scalability. So it's important to understand when we talk about voting, and while our goal is to bring that to society and to governance platforms and so on, when we design and when we think about it, we talk it as a collective signaling mechanism, right? That give cryptographic guarantees. That means this thing can be used for many other purposes, right? And we understand voting just this very primitive, but there is many other stuff that you can do with voting. And that's one of the reasons while on the last 2 years we've just been focusing on setting up this infrastructure and making this work and testing. We're still working on that. This is towards a much more concrete goal, which is the Vocdoni platform. In the Vocdoni platform, what we're trying to do is really create a platform that brings this technology to the hands of people, right? We realize that just by making like some sort of open source libraries, that's not enough to like have a real change, and that's why I was mentioning before that we want to go beyond the technology. So we're building a platform that our aim is for any organization, any user to be able to, at some point, do like a voting process that is more secure, it's more resilient, it's more censorship resistant than anything that we're used to, like even in the analog world, right? So we're building that. We'll have like a beta soon. And well, what I was mentioning before, right? That for voting, we mean voting, but all these things like are included with the idea of voting, right? Petition signing is nothing but like a collective signaling. And then on top of voting, you can have like many other systems like quadratic voting, liquid democracy, binding results. All of these are things that you can enable once you just have voting, right? So that's why it's so like why we try to summarize that all in this very little phrase at the very beginning, right? Like how can millions of people vote? Because like that's the primitive that we need in order to start like thinking and imagining like way beyond what we can do right now, right? And having something like a blockchain and with the security and being so trusted and so censorship resistant, we have a paradigm shift, right? Because now we have this collective signaling mechanism that we can use anytime, anywhere. It's more transparent, it's more accessible. It is a fraction of the cost of any like digital voting system that you have, and it's more resilient than that, right? And that's why we're going like to almost like one goal that we want, right? Like we want frictionless participation. We want people to believe again, like they can have an impact on the world, right? Like we're so abstracted out from what we're doing right now in society. Like no one believes in politics anymore, right? We vote once every 4 years, and for what? And so on and so on. So unless we have a technology like that, we cannot bring back that to the people, right? We cannot, engage with the organizations like any minute, right? How? We have to build it on top, and that's one of the things that Vocdoni as a platform want to do. But unless we have that, we cannot do that. It's important to point out that while we're doing this platform, we want this infrastructure to be shared, and we're looking for other organizations that can use this infrastructure for whatever it's like for governance or other means. We just want this system to be resilient and to be like have the guarantees that us as an entity on itself maybe cannot give. So just like a little timeline on how we start. October 2017, right? Catalonia has a pretty big censorship. Probably nothing to explain in this room. But that's what catalyzed, like, that's what triggered the project, right? Like, okay, we need like to do something here. Thanks to some generous donations, we could start the project. We did some real world testing on June, a couple years ago. We experimented a lot. That was like the first real test we got. At the beginning, we were using like using kind of a clone of Zcash and like sending tokens here and there, but we had to use like another. I'm not going to get deeper into that, but we've been iterating a lot on that. It took us a single year only to just have a design that was suitable for like the specifications that I mentioned at the beginning, that's universally verifiable, can work on a smartphone, et cetera, et cetera. And for the last year, November 2018, we created a team. It's been growing since then. On July, we made this change. Like we stopped being like just an open source project, and we say, okay, we need to bring that to the hands of the people. We need to distribute this technology. That's when the idea of the platform started like having shape. And since then, we've just been working pretty much on the infrastructure and creating these tools. We are now, we have the infrastructure working, the basics of it, and we're hoping the next month to start like a closed beta release for the platform. So if you have an organization and would like to test an early version of that and experiment, we're very happy to talk about like how we can, figure this out. It uses decentralized identities. It's all privacy-centric. It's GDPR compliant, all this shit. So you can find us Vocdoni on Twitter or Telegram. And now I'll leave you with Pau, who's gonna, the hardcore stuff.
A lot of people here. I'm happy to have the opportunity to explain the project. We have been, as Xavi said, almost 2 years working on that. And we have been working a bit in the shadow, and now it's we are opening the project, we're starting to make talks, and we're starting to create community around Vocdoni. So yeah, I don't have much time. The design, the architecture is quite complex. There are a lot of components, so I will make a quick overview on them. And then afterwards, at the end of the document, there is a link where you can find all the documentation. So you can spend some time looking at them if you are interested in some specific part. So yeah, let's start by the architecture overview. As I was saying, you can, I don't know. Okay, so mainly, yeah, one of the first things at the beginning, we didn't want to develop something new. We were trying to integrate stuff that already works. So this is why we try to use as much as possible things that are already on the field and working. So we have Ethereum, we're using also IPFS, we're using Swarm PSS, that maybe is not as known as the other projects, but it's like a IPFS PubSub system for sending messages between nodes in a distributed way. And we use Tendermint now, which is similar to Substrate, Polkadot, and all this stuff. It's the Cosmos-based technology. So let's talk first about the first component, which is probably the main component, which is Ethereum. Yeah, maybe in some years, Ethereum scales very well and we are able to make everything on Ethereum, but right now we are not in that moment and we want to release something soon. So for now, we're using Ethereum just for data integrity and a source of truth. So it's like the first, is the first place to look at. And from Ethereum, then you go to IPFS, you go to Tendermint, you go to Swarm, you go to everything. But Ethereum mainnet is like the source of truth for everything, for all the components. So yeah, we use IPFS for data availability. We are not attached to IPFS. We want to support other projects such as DAT or Swarm or any other distributed file system. But right now we are just using IPFS because it works. And we use it for store information. For instance, yeah, we have two different, let's say, actors on the platform. One is the entity or organization, and the others are the user of the entities. So the organization can have some metadata, some logo, some information regarding the entity. So this information lives inside IPFS. And the reference to this information is on Ethereum, right? So yeah, you can go to the next. Yeah, we have another piece, which is, we call it BotChain. That's a Tendermint-based custom blockchain. We have developed it just for accounting votes. So why? Because this is a very fast blockchain. It's a proof of authority. For now, in the future, we will try to open it a bit more and to distribute the miners and so on, making some kind of federation between trusted parties. But right now, we have all the nodes. So it's a kind of centralized blockchain, but for the phase where we are now, I think it's fine. In this blockchain, there are no tokens. There is no gas involved. It's a very simple blockchain that has a zero-knowledge snark validator integrated. And yeah, and that's it, mainly. I will show afterwards how it works. We have Swarm PSS, which is Academia DHT for distributing protocol messages between some components. I think we can go to the next. We have the gateways. That's probably right now the most important part of Vocdoni. The gateway is like the full node of Vocdoni. We have in a single program, we are running a WebSockets endpoint that will be used by the mobile phone app clients, an IPFS node, an Ethereum node, a Tendermint botchain node, and the Swarm PSS node. That sounds a bit crazy, like how can you put all these technologies in a single program? But yeah, we did it and it works quite well actually. You can go to the next. Yeah, we have this special piece which is called Oracle. The Oracle is the bridge between Ethereum, which is the source of truth, and the Tendermint blockchain. So yeah, whenever there is a new election, it is published on Ethereum, and then the Oracle creates a special transaction to the Tendermint blockchain, and then the process is alive on the Tendermint blockchain, and the users can start voting. We will see it also after. That's the whole set of components of Vocdoni. Here is like the user, and here is the entity organization manager. So the user uses the gateways to connect with the peer-to-peer networks. That's like the Tendermint part, that's the Ethereum part, this is the Oracle, yeah, and some other components. Okay, so that was like the list of main components of Vocdoni. And now let's see the voting process overview. So what happens in a voting process from the beginning to the end, right? So the first step is to create a census. If you are an entity, you need to have a list of users. Right now, we identify a user as a public key. So the entities need to have a list of valid users in some private database or some kind of ledger or something. We provide some solutions for that, so the entities can easily go to entities.vocdoni.io and then register and use the database and everything, which is GPDR compatible and so on. Or you can have your own database if you have enough resources and infrastructure for maintaining. So the first time you open the app of Vocdoni, you see nothing. Then you need to register to some entity, right? So then let's say you scan a QR code, which is the entity, the address of some entity, and then it finds it's on Ethereum, goes to IPFS, fetches the data and everything, and then you say, okay, I want to be part of this entity. Okay, so in that moment, you have a form which is provided by the entity where you put your information, and then this form is sent to the entity, and the entity, if the entity wants, validates you. So you are part of this entity. It means that your public key is on the private database of that entity. That's the only private part of Vocdoni, I would say, but it's something that we want to keep this way because that's a private user information and that has to live on some private infrastructure. So the entity keeps the census, this list of users and public keys. The next step would be to prepare the census. So once the entity wants to create an election process, it will get the list of public keys of this private database and will generate a Merkle tree, a very and well, I think you know, all of you probably what's a Merkle tree. I don't gonna explain it. And then this Merkle tree is serialized and exported to IPFS, right? So we have the root, the root hash of the Merkle tree, and we have the URI where to find this Merkle tree. Next step. Yeah.
How people knows there is no fake voters in the Merkle tree?
I mean, the census is something that the private entity needs to keep, and that's something that you must, if you trust the entity, you have to trust that the census is correct. As far as I know, there is no way that without publishing the private information from the user to know that if the entity is putting fake people or not fake people. But for instance, I can imagine in a city council, where there are maybe 1,000 people living there. If the census is 2,000 people, then something is wrong here, right? Yeah. And if the census is 1,000, but half of them are fake, it means that probably some people will try to vote and they won't be allowed to vote. So they can fake some votes, put some fake people, but I don't think that would be very relevant in the case of an election.
Yeah, that's like Yeah, you need to find what you want, right? The privacy of the people or the full acknowledgement of like. So this, you can mitigate that with audits, private audits, but I don't think there is like a cryptographic solution to know that a natural person is like in the census and all the natural persons are in the census,
Yeah.
right?
Yeah, I would say that digital voting is a very complex topic and it has a lot of problems, but I would say that most of the problems are social problems rather than technical problems. So, and we're trying to face the same problems that all the digital voting systems have, and yeah, we're doing the best we can here. So we have the census on the IPFS, right? Then the entity sends a transaction to Ethereum to a specific smart contract, which is the Vocdoni's process smart contract, with some information. In this case, the most relevant information is the root hash of the census, the URI where to find the census, the type of election that can be snark or polling or some others that we might include in the future, where to find the metadata for this election, let's say the candidates, the list of candidates, the programs, some text, some photos, everything. You can find it here in IPFS. All this information, the smartphone app will be able to fetch it and will be able to show it to the user as it was a centralized system, right? So it will have also when the election is starting, at which block of the Tendermint blockchain, and the number of blocks that will be alive, and some other information that I don't think is relevant right now. So yeah, once this is published on Ethereum, everyone is able to see that there is a new election from this entity, right? So let's say the election world map will be like the gateways. The gateways is a trustless component, a neutral component that anyone can have. I mean, we expect in the future that the people just run gateways to help Vocdoni cause, and maybe because you don't trust the gateway from someone else and you want to use your own gateway, so you will like have your own gateway at your place and then use your own gateway. So your gateway will see that in Ethereum there is a new election process and there is a new census. It will download the census and import to the local database. Why? Because the users need to get the Merkle proof, as they are part of this census. So for having this Merkle proof, they need to have access to the Merkle tree, and this Merkle tree needs to be available on the gateways. Then the Oracle will see that there is a new process on Ethereum, and it will create a new transaction for the Tendermint blockchain. Only the oracles are able to send these kind of transactions to Tendermint. The public key of the oracles are in the Genesis file of the Tendermint blockchain, so no one else can send this. This is a trust component, and in the future we want to like federate it and make it maybe we as Vocdoni we can have one oracle, but then some other entities around the world which are trust entities can have more oracles, and we could have some mechanism to vote about if something is valid or not between the oracles, but that is still in an early stage. Then, yeah, once the oracle sends a transaction to the blockchain, then the miners will include this transaction to the blockchain, and the election process will be open and available once the block 10,000 is mined, right? And yeah, and that's in case of if it's a private election, it means that no one can see the current status of the election. For instance, right now, in the normal elections, you vote, the people vote, but only in the end of the election, the people can read the results. So for hiding this information, there are some encryption keys, which at the beginning of the election, the public key is public, so anyone can use this public key for encrypting the vote, and at the end of the election, the private key will be published, and everyone can decrypt the votes and make the counting. Yeah, then The user warm up means that if you are a user, you have the smartphone app installed, and you are registered to that entity, you will see that there is a new process. Then the app will check if the user is able to vote, so trying to get the Merkle proof from a gateway. If you are able to get the Merkle proof, means that you are part of the census, means that you can vote, right? Fetch the metadata, fetch the encryption keys, and see when the election starts in UTC time. We can kind of translate the number of blocks in UTC time, because we know that there is one block every 3 or 5 seconds. It depends on the configuration of the Genesis file of the blockchain, and then we can estimate at which moment it will start. And then the election starts, right? So if you are an eligible app voter, then you can vote. You make your choice, summarize it in an integral right. That's for now, that's the way that we're using for voting, but in the future we might change that. Right now it's like, this means for the question 1, the option 1, for the question 2, the option 3, and for the question 3, the option 1. That's very easy to understand, very simple, and right, for now that's enough. Get the private key and encrypt the vote if it's a private election, and then compute the zero knowledge proof. We will talk about that afterwards, about how we use ZK proofs, but mainly with the private key and the Merkle proof, you can demonstrate that you are part of this census without saying who are you in this census, right? So you pack everything and send the transaction to the gateways. And that's also important, you save the nullifier. The nullifier is a number that only identifies your vote, but this number can only be computed by you because you have the private key. This nullifier depends on the private key, so only you know which is your nullifier. So you save it to check afterwards if your vote has been correctly counted on the election process.
Also to prevent double spending.
Yeah, with this number, you can, if you vote another time, you will generate the same nullifier. Then anyone will be able to know that the same user has voted twice, but without knowing who is this user, right? And then once this transaction is sent to the Tendermint blockchain, the miners will mine it if and only if the election process is alive, the proof is valid, and the nullifier has not been already used, right? That's it. So here the election ends because we are in the block number that finished the elections, right? If the election is private, the miners will publish the temporary private keys, so anyone can decrypt the content of the votes and can make the scrutiny. Yeah, something like this, to count to compute the results, and everything else. And that's once everything is done, the Oracle will also send back a transaction to Ethereum with the results. And that's only for the record. I mean, anyone can connect to the Tendermint blockchain, download all the blocks, and compute the results, and check that the results that the Oracle has sent to Ethereum are correct. So in this case, the Oracle only plays a helper role. Yeah, it's for lazy people. You don't want to compute your votes, but you can check. If you trust the Oracle, you can check on Ethereum what's the result.
Can I use the nullifier to check that my vote was what it really was, or just that it was counted?
I mean,
I voted yes.
no, but I think your question is related to how we use the ZK zero knowledge proofs. You can use the nullifier to identify your vote, and if someone has changed the option, your choice during this process, you can the zero knowledge proof won't be correct. So you need the vote, your choice, you need the nullifier, you need the process ID and some other information as public inputs for checking that the zero knowledge proof is correct. I will show you this afterwards with the diagram. So let's talk about this. No, let's wait here. So in the circuit of the ZK snark, we have these private inputs. We have the private key, the census Merkle proof, and the vote signature. This is for ensuring that no one on the way is changing your vote choice. So you take the data that will be counted as the election process, and then you will make a signature, and this will be one of the private inputs of the circuit for calculating the proof. So no one can change this, or the proof will be not valid. And these are the public inputs: the Merkle root, the nullifier, and the process ID and the vote, right? So the nullifier is the hash of the process ID, which is a, let's say, random and unique number for this election process, and the user private key. So only you are able to compute this nullifier because you are the only one knowing the private key, right? Yeah, that's the circuit. And yeah, I don't think we are able to see anything here, but this is the Merkle proof with the siblings and the index. This is the census root. This is the signature for the vote. This is the encrypted vote, and this is the process ID, and this is the nullifier. I think that's. Yeah, we can talk about that afterwards if you have some questions regarding the zero knowledge circuit, but for now I think that's enough. So we started using linkable ring signatures, which is another technique for analyzing your vote, and now thanks to Jordi, Bailina, and Adria, we are able to use the ZK snarks, which are much better because they scale much better than the linkable ring signatures. But in the future, maybe we will use some other techniques, like some kind of roll-up or something like this. We don't want to stick to any specific technology. We want to start doing things, start having people and users, and iterate over all the components that we have and the technologies that we're using. So yeah, that's it, yeah. Right?
We're hiring. We need product manager, backends, front ends. So I know if there is any developer, talk to us.
Yeah, all the code is here in GitLab. You can check it. Here we put a lot of effort on the documentation because we want to make everything transparent. So you can check the documentation here. And yeah, Twitter and Telegram are nice entry points for being part of this community.
Any question? Nice.
Yeah, he got a question.
Regarding reusing the nullifier, it could be a good use. It could be a good use case for trying to change your vote, right? Because
trying to what?
Is it a micro?
Interpretation.
Okay. When you try to reuse a unifier, normally it should be treated like a double spend if we are talking about money. But in the case of a vote, it could be you want to change your vote because you decided something, and then the last vote should count, right?
Yeah, so that's correct. So the nullifier will tell you that, okay, there is a user that has 2 votes. Then it's up to the application logic to decide which one is valid. And use cases, your example is I think it's a very good one, right? So if I'm, for example, if I have any kind of coercion, like I'm put up with a gun and say vote this, I vote this, and then 2 hours later I can go and change my vote. But other mechanisms may require other stuff that's just up to like how the computing logic. Yeah.
So there's something new that is called minimal anti-collision infrastructure that is working Barry and Italian guys. It's about change your vote with nobody noticing it, and might be something interesting just to check
Yeah.
Yeah.
in the next iteration.
Yeah.
So at the end of the election, if I know my vote and I know my nullifier, can I prove to you that I voted something? Or?
Uh-huh.
No, okay, great, fantastic.
Yeah,
You-
that's well.
If you have access to the private key, yeah. If you give away your private key, you can.
Oh, so then they can buy my vote easily, no?
Yeah.
Yeah.
I mean,
Well, I mean that's you.
if someone has your private key, like you're fucked. But that's the same in Bitcoin, that's the same in Ethereum, right?
Yeah, but
So what we need to do is to do mechanisms to mitigate this case. And one way that we're doing here is your private key is very core to your identity, right? So if you give away your private key, you will give away all your organizations, everything else.
But I can even produce a proof that,
Can you speak higher, person?
sorry, I could produce a proof that I voted something with
Yeah.
my private key without revealing my private
that's
key.
right. And that's one of the biggest problems that we have.
Okay.
The way we will probably mitigate that is, let's say in the snark, there will be a special, let's call it magic key, that with this magic key you can produce any valid snark. So at the end of the election, this magic key will be published, so anyone can produce any snark, and then you mitigate that problem. That's, yeah. If you have a better choice, we would like to.
Yeah, that's good, that's great.
You will only be able to prove during the voting process.
Yeah.
After once this magic key is proven, then all you can do is like, or I have my private key, or like I know that this public thing exists.
Yeah, and this magic key can be like a multi-party key, which is shared between several parties, like say trusted parties, and yeah. Only if all of them are agree, they will be able to make something bad. What, Jordi? You're moving in a strange way. That's your idea.
So you're still,
No.
that the way to go is what Andrea mentioned. It's
Yeah,
it's the
anti-collision.
process that you still can prove that it's nullified.
But that's like really very deep, like into like a very.
Here the idea is that you are able, the idea that goes is that you should be able to change your vote afterwards. So even if so you can prove that maybe you voted this at once, but it does not prove that you don't have a different vote later, so that you didn't change later. So the way to do it is a little bit more in that direction, that you need a centralized
Yeah.
authority for
Yeah. Yeah.
read the Vitalik's paper.
Yeah, no. But yeah, I agree. That's the biggest problem of all this thing. I think there was a question there.
Which part did you use the swarm PSS?
Yeah. Huh? In which part we use swarm PSS? We have something like IPFS cluster, but it's not IPFS cluster. We call it IPFS sync, and it uses swarm PSS for discovering other nodes. We also use it for, we have these boot nodes, which keep a list of working gateways. So each gateway for as a discovery mechanism, it uses some swarm PSS, like sending messages like, I exist, I am a gateway, I have this IP, this public key, and everything. So the boot nodes will collect this information and will show it to the users, and the users will have a list of working gateways, and they can choose which gateway to use, and so on. So it's like a PubSub mechanism.
Was there a problem with the IPFS PubSub that made you If you're running IPFS nodes, why didn't you use IPFS PubSub?
Yeah, we started using IPFS PubSub. Is there some IPFS developer here? It's, I mean, it's horrible. And yeah, we end up using Swarm PSS because we find it much better than PubSub. But maybe now or in the future it will change and we will go back to IPFS PubSub. Yeah. But we're also using Ethereum, so why not to use Swarm PSS, which is kind of part of Geth that we at the end we're using Geth.
So a validator on the Vod chain is running an IPFS node, is running a Vod chain node, and an Ethereum node. It's running 3 nodes,
Yeah.
all of them.
It's crazy.
And at the same time is maintaining the identity of the voters.
The identity of the what?
The identity of the voters, doing the census.
Yeah, right.
It's doing everything.
Everything, yeah. With yeah, you need at least 4 gigabytes of RAM memory for running this.
And why would you be a validator?
Of the bot chain, Tendermint.
Yeah, running all of that stack.
Why?
I'll say that this is not a concern now. It's about the technology. We're running that ourselves, right? And Vocdoni in itself will have validators in the network. When the things grows and when the if the process starts being challenging, the idea probably will be to use reputable organizations to provide these services. And then in any case, like extreme censorship, I think the willingness of the people probably it's enough to keep these things running. But if it's necessary, we could always light some sort of incentive layer and some sort of monetary mechanism.
Even if there's not an incentive layer, can I just run one and be a validator?
Yeah, that was a...
Yeah, I wouldn't use validator because they are not actually validators. They are full nodes.
But it's a proof of authority.
It's a proof of authority, and the miners, I mean, the idea is to distribute the miners of the proof of authority blockchain between trusted parties.
Which are the full nodes?
No, so there is the gateways, which are they have a full node, right? And are the ones that are relaying the both transactions, and those are like trustless components that are weak in the sense that they have an IP address, they can be attacked, right? But at the same time, they can be, anyone can spin them up. And then there is like the nodes of the blockchain itself, the validators, which these are the ones that only like a few set of reputable entities will run. Does that respond to the question?
Yeah, I just thought that
Yeah,
I can run a gateway very easily, but I can't be a validator very
Correct.
easily.
You cannot be a miner of the blockchain, of the voting blockchain. And also the idea maybe in the future is to add some token to Ethereum to pay for elections. So if you are an entity and you want to create a new election, you need to spend this token, right? And how much you have to pay, it can depend on the size of your census, for instance. And then this token or this money that will be managed by a smart contract on Ethereum can be distributed among the miners of the Tendermint blockchain. Something like that could work.
We tried very hard not to create an incentive mechanisms at start. We want to focus on building the things that we care and not do an ICO or something like that because we believe that it corrupts the project in so many ways because it forces a top-down design and you have like a promise. So that's something that is very common in this community to have the incentive systems really figure out at the beginning, right? Because what people want to know to invest, we left it for the latest.
As Adria said at the beginning, we focus on the user experience, meaning that we put a lot of efforts also in the mobile app, and we expect to have the app public on the market for this year. Let's say the first or the second quarter of this year.
Hopefully.
Yeah. So we want to bring to the people some way to start using these kind of technologies, even if that's not the best set of technologies that we might use. Yeah. Right.
Yeah. You said publishing the app in the App Store or whatever. Does it work without it? I mean, there is a web version of it?
That's not been our focus. We want to. And actually, thanks to web snarks that Jory is creating, the system should be compatible regardless from the app and from the web browser. The web browser, it's harder to optimize. And that's one of the reasons why we focus really on the app, because now we can create a zero-knowledge proof under like 10 seconds. And on the browser, now it's much more optimized, but last time was like a few minutes. But a lot of people are working on that, and it's probably going to be the next step. Because, I mean, App Store are gatekeepers, right? Like, it's very easy for anyone to come say, hey, please just remove this app from the App Store, and everything is fucked up.
Yeah, we're also using Flutter as a base framework for the mobile phone application, and I think Flutter, I don't know if right now is working, but the idea is to have the same version of Flutter. You can have an app for the phone, a web for the browser, and a desktop application for Linux or Windows or macOS.
Yeah.
So yeah.
Microphone.
Yeah. Okay, so a little bit of a non-technical, more logistic question. Could you tell us more about the beta process, if you are contacting some organizations in order to run some initial tests? And I'm interested also in how the organizations are receiving this kind of project. Is there hesitation? Is there like full in, yes, we want to do this? How is the human part of the interaction?
So the organizations that we've been contacting are like people that sign up on a form that we have on the website. There's not that many, and now we're just running interviews with all of them to just fully understand what their needs are, right? A lot of projects and a lot of the interest that we had so far is not coming from an organization that wants to use a platform, because I'm assuming that something is just hard to understand, right? We still don't have the things in place to show what we can do. The most of the interest has been coming from other projects that are interested in having an anonymous voting layer. And that's something that we're supporting on the side, and we want to. Projects like the CIDIM here in Barcelona is very well known. They do not need a solution like that, right? And like that, there's other projects that they just need an API for secure anonymous voting. So we're investigating that, because it probably can also provide us a revenue and sustain the project early on. But it has some difficulties since most of these projects will require a web version to run, and that's like in an earlier stage than that we have on the app. So we're trying to figure out. So far, the overall reception is pretty cool. The ideas, like, I think people like what we're proposing. We try to be really grounded about what we're doing. We don't want to sell bullshit of any type, right? And it's going to be slow. Running everything decentralized and making frictionless, it's tough, right? So our initial version of the app is probably going to be very limited. It's going to be about just voting, but we do have a lot of ideas that go beyond just simple voting and participation and proposals, and we want to experience that. But that's going to take time. So I'm assuming a lot of the early on organizations that we have, and actually that's been most of the people I contacted, is people in the crypto space. It's people that's familiar with the stack that we're proposing, that it's been following these ideas. For example, one thing that's limiting for us right now, it's the administrator of the organization needs to use MetaMask to use a web interface to make transactions on Ethereum and stuff. That's a no-go for us, but it's what we have. The user doesn't need to do anything of that, which is great. But you at least need an organization that has one person that knows how to use MetaMask and know how to get some ETH and all this stuff, right? and a limitation that comes from that is like, okay, you can only have one administrator right now to manage the census and that's very limiting. That means probably there's some organizations that, you know, you cannot give that to someone else, right? And who's controlling the keys and all. So these are the next things that we want to focus on, like meta transactions, better integration, like not using web interface. You can have like everything integrated in one single package. So it's on the pipeline.
Thank you very much for coming. Guillem, that is also organizer of the blockchain community here, is going to do a meetup just showing the Holoboard, that is a hardware just for running Holochain. So it's also really interesting. So you can check on Meetup also, this meetup. So just to say that. So thank you very much.
Thank you.